Okay, hello everyone. In this video, we're actually going to be discussing a different way of proving that something is not regular. Everything really stems from the pumping lemma in this set in these sets of videos, but using the closure properties is kind of a way of saving yourself a pumping lemma when you know what languages are already not regular. Okay? So how can you use the closure properties to actually show that something is not regular? Well, you're going to sort of do this by contradiction. So what you're going to do is, if you're trying to show that some language L is not regular, you assume, for the purpose of contradiction, that it is in fact regular, right? So that's typically how a proof by contradiction works. You're trying to prove P, instead you assume not P, right? Now, what you're going to do is you're going to take this language L, which you've now assumed is regular, and you're going to manipulate it using operations you know are regular languages are closed under, right? So, for instance, you can manipulate the language L with a complement, with a union, with an intersection, because all of these operations, when you take some language L and you union it with some language L prime, if both of these languages are regular, then the union will also be regular, right? So that's the idea, is that you want to manipulate this language L using the closure properties to produce or return another language, let's call it L prime, which, because regular languages are closed under these operations, right, you'll have concluded that some new language L prime is regular when you already know that this is not the case. And so that's where the contradiction comes from. This is your contradiction. So a quick example of this, okay, just because this might seem very hand-wavy, is consider the language W over the alphabet. Well, consider a language over the alphabet AB, which is a set of strings where the number of A's in that string is equal to the number of B's in that string. And so the claim is that this is not regular. Okay. Now, suppose, for contradiction, that it is. Now take this language L and intersect it with the language denoted by the regular expression A star B star, right? So in other words, L is all the strings that have an equal number of A's and B's. Wait, this one doesn't. Okay. Now what we're going to do is we're going to intersect it with L A star B star. Right? And this is a regular language, right? This is a regular language, obviously, because a regular expression denotes it. But what this essentially does is that it filters out all of the strings in L which don't look like A star B star, right? And so, because what A star B star is, it's just any number of A's followed by any number of B's. And so what happens is that these strings get filtered out, and the only strings that remain, right, the only strings that remain are the strings that have an equal number of A's and B's, and that start with A's and end with B's, right? So for instance, AA, BP, right? And so really what this operation does is that it filters, right? It filters L, right, to produce a language that has both of the properties. That's what the intersection does. So it creates a language L prime where the strings in L prime have an equal number of A's and B's, and the strings start with A's and finish with B's, which means that the strings in L prime look like AN, BN, right? Okay. But what have we done here? We've assumed, right? We've assumed L to be regular. Then we've taken L intersect with another regular language, right? So this is regular. We assume this is regular. So then we must get another regular language, right? Which means we conclude that AN BN is regular. And this is clearly a contradiction. That's my symbol for contradiction, right? This is clearly a contradiction, which means that our initial assumption was incorrect, right? So the assumption of assuming that L was regular was incorrect, which means that L was in fact not regular. Okay, so this is the general template of how to use closure properties to prove that a language is not regular. You take that language, you manipulate it some way. Often the regular expressions are very helpful because they allow you to filter for some patterns. But other operations like the complement, the intersection, the union even, can also be helpful. Okay. Okay, so that's the general idea, and then we're going to look at some exercises, of course.